This is an A-level Further Mechanics 1 question on elastic collisions in 2 dimensions, and this is successive oblique impacts. Figure 2 represents the plan view of part of a horizontal floor where AB and BC are fixed vertical walls with AB perpendicular to BC. A small ball is projected along the floor towards AB with speed 6 meters per second on a path that makes an angle alpha with AB where tan alpha is equal to 4/3. The ball hits AB and then hits BC. Immediately after hitting AB, the ball is moving at an angle beta to AB where tan beta equals 1/3. The coefficient of restitution between the ball and AB is E. The coefficient of restitution between the ball and BC is 1/2. By modelling the ball as a particle and the floor and walls as being smooth, part A show that the value of E is equal to 1/4. So we'll start by looking at any information that's in the question that's not on the diagram. So for example, tan alpha, tan beta, that's not on the diagram. We have the coefficient of restitution of BC as 1/2. Let's put that there. And the coefficient of restitution of AB is E, and that's what we need to find. Right, so let's start putting the components of these velocities on. Right, so we'll start over here. So we'll have 6 sine alpha, and here 6 cos alpha. And if we move on to the rebound, remember these are going to be equal. Now I'm going to introduce an unknown. I'm going to introduce V for this velocity here so that I can write the rebound velocity parallel to the wall as V cos beta, and then the one perpendicular to the wall here, this can be written as V sine beta, but it can also be written as this times by E, so 6E sine alpha. So I'll just put equal to 6E sine alpha, and then I'll just finish off with these velocities here. So basically this one's going to be the same as this, so I'll write it out again, I guess. So V sine beta equal to 6E sine alpha, and here this one will just be this velocity, or even this one, times by 1/2. So let's write this as either 3 cos alpha, or we can write it as V over 2 cos beta. Now let's have a think about this. I want to find E, so I basically want to combine something to get an equation for E. Now I've got an E here which is equal to V sine beta. I've also got a V cos beta here. Now if I do V sine beta divided by V cos beta, that is tan beta. Right, that gives me some sort of way of getting into this. So I'll just put down that this tan beta is equal to 1/3, which is equal to sine beta over cos beta. Now we have V sine beta, so the V's are going to cancel out, because at the bottom I will have V cos beta. Now this V sine beta can be written as 6E sine alpha, so this is equal to 6E sine alpha over, now V cos beta is equal to 6 cos alpha, so I can write over 6 cos alpha. So let's see what we've got so far. With the 6's cancelling out, I have 1/3, which is the tan beta, is equal to E times by tan alpha. Now this is a common result, but you can't just use the equation tan beta is equal to E tan alpha, you must prove it here. So tan alpha, that is 4/3. So I've got 1/3 is equal to E times by 4/3. So basically E is equal to 1/3 times by 3/4, which is 1/4 as required. So once again, don't go straight to tan beta is equal to E tan alpha, because you won't get the marks for the proof. You must start from the information that's here. Don't jump straight to this. Part B, find the speed of the ball immediately after it hits BC. So this is the speed, not the velocity, and we'll need the velocities for the speed. So basically this is what we need to find here. So to find the speed, I want basically what this part is here and this part here, and I want to do Pythagoras on them. Now since I don't know what V is, I want to use values here that don't involve V. Now the component which is in this direction, so this one here, this V over 2 cos beta, well that's equal to half of this, because these are the same, so half times 6 cos alpha, which is equal to 3 cos alpha. Okay, so that's what I can write for this part here. So let me put that down. So this is the same as 3 cos alpha. And then I can do the same for this component, use the bit with the 6e sine alpha. So this component here, that is 6e sine alpha. Now we worked out in part A that E is a quarter. So 6 times a quarter sine alpha, and so that will be 3/2 sine alpha. Now we were told that tan alpha is 4/3, so we can use triangle to work out the exact values of sine alpha and cos alpha. It's got a right angle triangle here. There's our alpha, 4/3, so opposite over adjacent. Hypotenuse is 5, so that will give me cos alpha is equal to 3/5, and sine alpha is equal to 4/5. So now my velocity, which is perpendicular to BC, this part here, after the second collision, is going to be 3 cos alpha, which is then equal to 3 times by 3/5, because that's cos alpha, which is 9/5. And then this part here, which is equal to 3/2 sine alpha, will be 3/2 times by sine alpha, which is 4/5. And that's 12/10, simplifying to 6/5. So the speed is going to be the square root of 9/5 squared plus 6/5 squared, and that gives an exact value of 3√13/5. So you could give that exact value if you want to, or, and this is in meters per second, if I press my SD button, I've got 2.1633, so on. And if I gave that to 3 significant figures, that would be 2.16, 3 significant figures. So even one of those, and that is meters per second. I'd go for the exact one. And part C suggests 2 ways in which the model could be refined to make it more realistic. So you can pick any 2 of these. Include friction between the ball and the walls, or include friction between the ball and the floor. I've not written the whole sentence out. Now these we can get straight from the start of the question, where it says that the ball and the walls are modelled as smooth. So you can just pick that out, and that can give you two reasons. Include the dimensions of the ball. That's another one we could have. We could include the spin or rotation of the ball, or we could include air resistance. So any one of these, or any two of these, will get you the marks.